Welcome to Bates. I'm Landon Johnson, and I'll be your guide today as we explore our Industrial Automation and Mechatronics program, currently located here at Central Campus and enrolling students year-round. When it comes to automation and robotics, one of the first things I get questions about is the loss of jobs to robots. Yes, automation will remove some targeted jobs from the workplace, but what many don't get is that the automation industry itself will add jobs to the market. Someone has to design, repair, program, sell, buy, and maintain these machines which provide the automation. Unskilled jobs will yield to jobs that require skills, like the ones we teach here. One path around this dilemma is through education. Our Industrial Automation and Robotics program provides the type and caliber of training your future employers require to be successful. How do we know? We meet with them twice a year to get their input, and we modify our delivery accordingly so that your future employer gets exactly what they need to make you successful. So let's head on in and have a look at some of the things you'll be working with in our program. In general, the theory portion of the material is taught online, as well as some of the lab work through simulation. Additionally, we feature many hands-on activities on campus because, as any technician will tell you, thinking about it and touching it are two completely different things. Okay, so here we are at our Industrial Application Center, where we have roughly half of our hands-on equipment available. Through the window here, that we have a FANUC robot playing chess, and we have a couple of SMC training devices that we use to help students learn how to program PLC. So let's head on in and have a look around, shall we? So this is a lot more like the production environment of the 21st century. Well lit, ergonomic, environmentally stable, and clean. I guess we'll do that one. Production environment of the 21st century. Well lit, ergonomic, environmentally stable, and clean. So we have a lot going on here. Although all these devices that we have in this room look somewhat similar, and they are, the ones over here on the left are 3D printers, and the ones on the right over here are CNC milling machines. Each one has its own computer, so they can all be independently controlled. So the difference between these two is over here where we have our 3D printers, we are making big ones out of little ones. It's called additive manufacturing. And over here with our CNC machines, we are making little ones out of big ones, doing what is called subtractive manufacturing. Learn how simple CNC machines are programmed and how that fits into the mechatronics and industrial automation environment as a whole. Our FANUC robot is part of a system that is designed to teach robot pendant programming. We use a training pendant like the one you see here to be able to program individual steps into the robot. Once the unit is switched over here to the auto position, you can see the auto switch. Once it switches over to the auto position, the robot will then move and execute the program that has been installed into it. Here we are working with chess pieces and grippers, whereas students have designed chess pieces and the gripper associated with it to be able to move the chess piece around. So we program all of those moves into the FANUC, one move at a time, and then run the whole slew as one program, and it moves the chess pieces from one place to another. Note that this is the same exact programming process used at Amazon and Boeing, as well as a host of other employers. We use the same language and equipment that they use. Electronics labs, where students can practice the hands-on skills necessary to get the requisite knowledge in basic electronics. We talk about AC, DC, three-phase, motor controls, filters, digital, and a host of other topics in the strict or pure electronics realm. Our labs, as well as the program culture, are designed with the tinkerer in mind, as it's always the tinkerer who comes up with innovative ways to solve or prevent problems, and in general, that's pretty much what we do here. Students are welcome to come up with their own projects to suit their own interests, and as long as the course outcomes are met, they can earn credit for their individual projects. Training station allows students to explore PLC programming using hands-on equipment, and the equipment itself mimics many of the different things or motions or activities that would take place on a factory floor. These particular devices utilize pneumatics. They utilize PLC control. And we have an interface over here so that students can explore the wiring between all of the different parts. And then we have our control center for our pneumatic energy, which controls grippers and motors and things like that on this piece of equipment. So students start out with absolutely nothing and need to develop every step of this program in order to make this device function in a number of different ways. And the beauty of this is we have not just one, but we have 4 of these. Each one is different. I have 2 in this lab. 2 are currently in storage and will be taking their place here shortly. So the SMC devices are used later in the program, and they are used to tie all of the things that are done in earlier quarters together in simulating an actual manufacturing function. So I hope you've enjoyed this little tour of our hands-on facility. If you'd like to get in on the fun and avoid changes in the unskilled labor market, you can stop by our website at www.batestech.edu or wait for the credits to roll, and there'll be an opportunity to contact me directly to ask any questions that you might have. So, again, thanks for stopping by. Later.